Hi everyone, welcome back to the channel. Today the topic is Flutter decentralized application development. So as you know, in the last few videos, I was primarily focusing on the sort of quote-unquote backend stuff. So I was talking about the Solana smart contract development, the Rust definition of your smart contracts, etc. Now it's the other side. It's the upstream side, the client side that calls these smart contracts. Today, I'll be primarily like a lot of the concepts that I'm talking about today are really not Solana specific, even though um, I will call out maybe, if I find anything here that might be very Solana specific, I will call it out. But most of it is actually applicable to any blockchain that you're using. It doesn't have to be Solana. A lot of the concepts here are more around, wallet integration, security concerns. What does it mean to have like a well-architected application that has clear separation of concerns and is extensible, things like that. So that's what today's session is all about. Next video is going to be a lot more specific, and there will be a lot of Solana specific things in that video from a client side perspective. So next video, yes, it will be very, very clearly how does a Flutter application talk to a Solana blockchain smart contract, and that's super clear. But today is more high level. But we are going to go deep into the details of how to configure the integration of your wallet with Phantom specifically, of your app with Phantom specifically. So hopefully you'll get a lot of this video today. It's jam-packed full of details. So let's get started. So let's talk a little bit about some of the architecture sort of concerns and things that I had in mind when I started. So all of this, as you know, I've mentioned this in my past videos. I have a business. One of my companies is basically a farm that I have that produces high quality wine, and I am basically developing this e-commerce decentralized application to serve as the one of the channels that I'm going to be using to sell the produce of the farm. So this basically, I've been building this platform over the last few months, and I've been doing it all on my own. I should probably get some help, but I've been doing this on my own. And I've been learning quite a lot just by doing this. And what this is one of the things that triggered me to want to do this YouTube channel is to say, look, I've learned so much. I've banged my head against the wall so many times. I've invested and so many hours of my day over the last few months to actually learn a lot of these things and stumble upon a lot of tips and tricks that you can use to speed up your development, and so that you don't have to face the same challenges that I did. And in this video, again, I'll be sharing some of those learnings and some of those things so that you don't have to go through the same, especially, for instance, when it comes to the Phantom wallet integration with the app, and especially because I chose a Flutter application, which is not the sort of the default recommended client sort of framework that the Solana team kind of recommends that we go with. So they don't obviously talk about Flutter, they talk about like the usual JavaScript frameworks like React and other things. So I chose not to go that path. I chose Flutter. So let's get started. So DApp architecture. So in sort of developing a decentralized application, there are sort of, at least for me personally, there were three key elements to balance: the decentralization, which is basically a spectrum. It's not like we're going to say it's either centralized or decentralized. It's binary. It's kind of a spectrum. The security aspects is another, important concern, at least for me, and I think it should be for you as well, is that, you want your applications to be as secure as possible. And you want, excellent user experience. So you don't want the user to feel like this, in order to use this DApp, it's different from your traditional Web 2 applications. It should feel very familiar to them. They shouldn't even know they're using a Web 3 application or a DApp. To them, it should be the same thing. And if anything, the user experience should be as good as Web 2, if not better. I think I mentioned this in one of my previous videos. So the challenge is really to finding the right mix of these sort of three competing goals, especially if you're building an application where sort of the end users are not sort of deeply technical, like the one that I've just mentioned. You really have to make this sort of juggling sort of between these three things: security, user experience, decentralization. So for my DApp, I prioritized these objectives because first I wanted to see how far can I go without using any centralized components whatsoever. I've mentioned this before, but that means that I don't want to rely on centralized servers or services if I can help it. So things like AWS or Azure or anything like that, GCP. I don't want to be using any of those services. Let's see how far. Maybe I won't. Maybe I will have to use some web hosting, but I'm also investigating web hosting options. One of which is obviously Shadow Drive. I'll mention Shadow Drive shortly, but I'm looking at decentralized options for virtually everything that I'm doing with this application. Again, it's not so much because of the censorship concerns that I have, because for an e-commerce platform type of application, one would think that you will not be so concerned about these types of things. You would probably be more concerned about this if I were building the next Twitter or the next social media app or news application or whatever. Then I would be extremely concerned about censorship resistance being one of the key features of the app. But for this kind of application, for my particular use case, which is e-commerce, this is not so much a concern. But still, I wanted to see how far can I go without using centralized components, because it's kind of a thing that I'm trying to prove to myself. What else do we need built in the Web3 space that allows us to be completely decentralized, not just from a back-end point of view, but also from a front-end point of view. Because I think a lot of the and I'll do a video at some point in the future about this topic, because I think it's a topic that is worth considering, and even we should come up with a definition for what it means to have a sorry for the noise outside. We need to have like a conversation about like what is the definition of a decentralized application. Again, as I said, there is a spectrum, and we need to define what that is. So what are the key features that we need to look for, and how do we score an application in kind of a scale on how decentralized it is? Because a lot of the dApps in existence today, we call them dApps, but they are really dApps to a degree, in the sense that most of the front end is actually using a lot of centralized components, and they're being hosted in centralized servers. But yeah, so anyway, this is a big tangent, but I just wanted to say that, in the future, I'll do a video on this. Yeah, and so when considering sort of the framework I wanted to use, as I said, I went with Flutter because it's one of the few modern sort of cross-platform frameworks that allows you to target mobile and web using the same code base, which obviously means less overhead, when fixing defects. I have to fix it in iOS and Android and web and whatever. No, I want to just fix it in one place and have it all available. Or if I have a new feature, I want to develop it once and it's available in all platforms. So Flutter is perfect for this. I don't think a lot of the other cross-platform approaches are as well developed as Flutter is, and also Flutter has this nice native look and feel, which again, some of the others you don't really get this kind of thing. And it uses Dart as the programming language, which is a very modern and scalable language, which is also backed by Google. So it's it gives me a lot of confidence that in its sort of longevity. Flutter also has like a massive user sort of community out there that are always willing to help you if you have any problems. So yeah, it's definitely a recommended cross-platform approach. Microsoft also has a good one that I've used in the past, but let's not go into that. But Flutter is the one that I chose. So in terms of one of the concepts that I relied heavily on when trying to develop this application is dependency injection. So specifically for using the Dart equivalent of interfaces. So in Dart, we have like abstract classes. And I modeled, for instance, the blockchain and wallet dependencies as these sort of interfaces that allow me to then implement those interfaces specifically for, in this case, for the Solana blockchain and the Phantom wallet, but I could easily extend this to other blockchains or other wallets. So this separation of concerns and is one of the things that I really was very, very keen on when developing this application, because I wanted really to have this freedom to plug and play different external dependencies without being too tied into a specific blockchain or a specific wallet. I wanted that freedom to change or even to evolve, so that the app in the future, for example, could ask me, what blockchain do you want to connect to and what wallet do you want to use? That would be amazing. Currently, I've only developed the what wallet do you want to use, even though I only implemented the Phantom wallet, but I could easily see a future where I give the user the options of choosing which blockchain they want to run the DApp on. So that's that. Yeah, so let's talk a little bit about the general architecture. So I'm not very good at drawing a lot of diagrams, but I think this is what I've done my best to kind of make this one as good to look at as possible. So let's just take a moment to walk through this architecture diagram and outline kind of the key components of this e-commerce application. So at the center of this diagram, you have the controller, which kind of acts as the central orchestrator of all the sort of interactions. The controller is responsible for managing both the read and write operations by communicating sort of with different external systems. It contains sort of most of the business logic, as we basically want to keep the views as simple as possible and only being used to render content for the users. And that's what the views kind of should be. It's mainly about the UI and nothing more. So in our sort of setup, the controller interacts with two key entities, as I talked about earlier: the Solana blockchain, which is one of them, which is this one here, and then the wallet on this side. So the controller kind of talks to both of them. How how does the controller know which one it should talk to? So in operations that require customer approval, we should have so for example, operations like connecting to your wallet or sending transactions where kind of funds are transferred, they obviously require approval, and in this case the controller communicates directly with the phantom wallet, logically. This communication, as the diagram shows, can be either done via JS Interop or JavaScript Interop, or via deep linking when we're talking about the sort of mobile space. So I'll show you all of those details in a minute, but this is basically the two sort of integration approaches that I kind of had to develop to make this Flutter application talk to seamlessly to the Phantom wallet, either as a browser extension or as an already sort of individual individual app installed on the phone, downloaded from the App Store. So the other, as I was saying, the other type of operation are read operations. So for operations that basically involve reading from the blockchain, such as fetching product data, which is stored in the smart contract, no user approval is required for those types of operations. So in that case, the controller communicates directly with the Solana blockchain and via the RPC layer, the remote procedure call layer. So this is a pure read operation, allowing the app to gather all of that necessary information. Another example could be, for example, I have situations where I retrieve the admin account because I want to read what's the last index like for this data that I'm going to save, or I want to get all the shipping rules or the promotions that are applicable, that could be applicable to the products that the customer has selected, things like that. You can just read from the blockchain without any approval being required from the customer, in which case you don't need to go through the wallet. So hence why the controller goes directly to the blockchain object as opposed to going to the wallet one. Hopefully that made sense. Yeah, and I'm not going to spend too long talking about these other ones here, but they are obvious if you've used the model view controller type approach to design your front-end applications. You know what these are. So you have your as I said, this is all about UI, UX, and rendering the data on the screens. So this is all effectively all the screens that the application has. In here you have your model. So this is your data, your data structures. A lot of these are going to be, as you can imagine, they're going to be accounts, Solana accounts that belong to your program, to your Solana program. So these are going to be mapped into Solana accounts effectively. And then you have your utilities. This utils folder has a ton of stuff in there, from data transformation to shared UI, for example, if I have an application bar that gets replicated in every screen, I could have that code in there. So code reuse, that's basically what this is all about. Like anything that is not specific to any of the models or the views of the controller itself, and if it's reused multiple times in multiple places in the application, that kind of ends up in the utils. That's it, really. Oh, by the way, I should also mention the Shadow Drive and Solana naming service. So these are two decentralized components that I also decided to use. Shadow Drive is obvious. It's a decentralized file storage and hosting. So currently I'm using Shadow Drive. I don't know if this is what I'm going to go live with, but so far so good. My experience of using Shadow Drive has been great. It's fast. It was easy to use to upload, to create my account and upload the files in there. The next step that I'm going to try is to upload my web app, my compiled Flutter web app into Shadow Drive and see if the hosting works well from there. I suspect I'm going to have some challenges with this because I don't think the folder structure kind of exists in Shadow Drive, so I will probably have to remove folders, kind of manipulate the app in such a way that I remove all the folder structures and have like a flat structure, and then just upload all the files in there and see if it works. But I'm also investigating other potential options for hosting the app, the web app as a whole, as opposed to individual files, which I'm currently doing on Shadow Drive. And then we have the SNS, the Solana naming service. And yeah, I mean, I've defined these two already. I've defined this. This is the name of the application with the domain name that I already registered for myself. And this is, in the Brave browser, you can actually enter this URL directly and it works, which is great because it's a Web3 sort of aware browser, while this one is the one that you would need to use if you're using Chrome, for example. But it's fine. I mean, either one works. And what this does is it basically redirects to a file that I have hosted on Shadow Drive. So it's kind of funny. So far, so good. The proof whether I can remain completely decentralized is whether I can, either with Shadow Drive or something else, I can actually host the whole application in a fully decentralized manner, and also in a way that is also scalable. So if a lot of people start accessing the platform, does it cope with that volume? So I have to do a lot of due diligence and research on whether these decentralized approach or decentralized ways of hosting the web app are actually highly scalable. That's one of my concerns that I have to sort of investigate, and I'll keep you posted on that. But so far, I'm happy with what I found. Yeah, so that's the architecture. So let's move on to the screen flow. So in terms of the screen flow, what do I want to say? So obviously, I have to say that obviously everything starts from the user's perspective, from this pointer here. And when the user, either on the browser or on the phone, when they download the app from the App Store, when they try to launch it for the first time, the app detects whether the user has already made a wallet selection. And if it has, then it doesn't go there anymore. It basically just goes to Wallet Connect screen. So this is only on the very first instance where you run the app. It detects whether you've already selected the wallet. Basically, I only implemented the Phantom wallet, so that's the only option for now. But in the future, I obviously plan to support other Solana wallets, like Backpack, for example, and others. But for now, it's only Phantom. So you select Phantom, and then you go to this Wallet Connect. Next time you launch the app, it doesn't show you that anymore because it saved your preferences, so you go straight to Wallet Connect. And when you are in this screen, you're shown a big sort of fat button in the middle of the screen saying connect your wallet. And when you click on that button, if it's the first, like if the app detects that it's one of the first times that you're trying to connect, it basically asks, there's a pop-up on the wallet that asks you to connect. You click yes, approve, and then you are taken to the homepage. In the homepage, currently it's a very simple homepage. It only shows like a list of products. In the future, it will probably be a little bit different, maybe a landing page where the product selection page will be a different one. But for the time being, I kind of merged the homepage and the product selection kind of in one because I didn't want to make things too complicated. And this also merges another functionality, which is this one that I'm showing here, which is if the application detects that it's the first time that you're running and you've not even created a profile yet in the application, it asks, there is only one, it doesn't even show you the products. It basically shows you a button saying, uh, um, create an account. And then at that point, you click that button, it creates an account in Solana, asks you to charge your Solana wallet for a few pennies just to create the Solana account. And by the way, when you close the account, most of those pennies are returned back to you. But anyway, you probably remember this when I mentioned this in the Solana smart contract sort of development videos that I've done in the past. I did mention this, but anyway, so this is one of the steps. If you've already created, you only see this once because once it's created, it never asks you again. So it shows you as soon as you connect, it shows you the products immediately. And then from this point onwards, when you select the product and you say place the order, if you've already entered shipping details in the past, it goes straight into the order confirmation screen. If not, it asks you for shipping details. Very, very straightforward. Very much like an e-commerce platform. But what I'm trying to do with all of these things is to try and minimize the number of clicks that you as a user have to do in order to get your products. So again, it remembers that you've entered shipping details, so you go straight to order confirmation once you select your products. It's almost like the Amazon one-click kind of experience. That's what I'm trying to do here, which is effectively that, because if you consider like you click on you select your products, then you place order, go to order confirmation. Is everything okay? Yes, boom, done, transaction complete. No enter your card details or anything like that. Why? Because of course you have your wallet. This is one of the massive advantages of, from a user experience point of view, of using decentralized applications like this, is that it's built in by default. These are monetary networks, and these apps live in monetary networks. So this is one of the massive advantages of doing decentralized apps for e-commerce purposes. I can see a lot of business just doing this for the next few years, converting their traditional Web 2 to Web 3 sites as more and more people kind of get onboarded into Web 3. Yeah, so this is really all I had to say about the screen flow. Let me just check my notes to see if there is anything in here that I need to talk about. Oh yeah, so there is this, so one of the aspects of, and connecting to the first slide where when I was talking about the architecture objectives of maximizing user experience, security, and decentralization. In that context, when I was creating this order confirmation screen, I went through it. I went into a journey of how to best achieve this, and I went backwards and forwards in my design choice on this a few times. Because initially, if you think about what order confirmation is to basically ask the customer, are you okay with all the selections you've done? And by the way, this is the total amount that you're going to be charged. This is actually easier said than done, especially if you're talking about the decentralized application. Why? Because on one hand, I was trying to avoid having complex logic like this in the front-end client. I wanted all these important business logic rules implemented in the backend as normal. Traditionally, in any business application that you think about, you typically have the front end being as dumb as possible. Front ends are supposed to be mainly presentation layers. and then you have your backends with all of your logic implemented on them. And I was trying to kind of follow that same approach that we use for Web 2 for Web 3. But in this case, I hit a brick wall. And the brick wall was that if I want to do, even if I want to run a simple, and again, remember, I'm trying to keep decentralization as much as possible. So I don't have like the luxury of having an AWS platform where I can put some microservice in there that kind of does all of these calculations for me in the backend, because I don't want to keep them in the front end. So I don't have that luxury as well. So if I'm only trying to keep, strictly speaking, Solana as my backend, if I, excluding the shadow drive stuff, which is my more kind of static storage of things. So if I'm trying to just keep Solana as my only backend, at least so far, I was like thinking, okay, that's fine. I can create an instruction in the Solana program where I can create I can have an instruction there called, let's say, calculate total or something like that, where it gets the purchase order as an argument, and then effectively it can run all the calculations in there. Well, this is at first seems to be logical, like seems to be a simple enough thing to do. But once you start going into the nitty gritty of it, you start realizing that actually this is easier said than done for a multitude of different reasons. First, the smart contract, when you call that instruction, it needs to be supplied with everything it needs to execute properly. And you would need to send a dynamic number of accounts actually to this instruction, because one of the things this instruction needs in order to be able to calculate the total is, at least it needs, for instance, one of the things that I designed into this application is the capability of having multiple, promotions being listed for multitude different products, shipping rules as well. So all of these things resulted in a variable number of accounts potentially being needed in order for this calculation to be done in the Solana instruction. So this is a little bit problematic. It's possible to do, but a little bit cumbersome to do. The other thing that was, and this was kind of the main thing that drove me away from this decision, which initially sounded like logical, but then I decided against it, was the calculation itself consumes computational units, and this needs to charge the customer. Now, if I'm going to charge the customer just to tell them how much this is going to cost, that's introducing friction that they're not used to, and it's also not very intuitive. So it would probably put people off from even wanting to continue in this journey. So this is not what the traditional Web 2 sort of e-commerce experience looks like. And it would effectively be turning this Web 3 e-commerce solution worse than its Web 2 counterpart. So and there was one more reason that I can think about right now. I don't remember now what it was, but effectively that I started finding lots of different reasons why this decision was not a good decision. So again, in order to maximize security, maximize the user experience, and be as decentralized as possible, I started kind of thinking, you know what, I'm going to implement this in the front end. And this is what I've done. So I've implemented the order calculation in the front end, because the front end can easily extract the promotions, shipping rules, all of these things. You can easily query the blockchain where these things are stored, and then it can run the calculation and run the estimates directly on the front end, and give a very, very good approximate estimate of how much this transaction is going to be. Now, it can never give you the precise amount, because that's going to obviously requires you to know, for instance, the transaction fees and things like that. But in Solana, because these things are very cheap, pennies or fraction of pennies, the estimate that you calculate on the front end is actually pretty accurate. So, and you can even use clever things like, average transaction, you could even figure out like what's the average transaction cost currently in the Solana blockchain. You could, I can think of ways of getting that number, but even if you don't want to, it's fine. It typically doesn't vary too much, and you can give the customer an idea of how much this is going to be. And it's not a problem because in the end they see the number come up in the wallet for approval anyway, so they can always reject if they don't agree with it, or if it's too different from what the app told them and they're not happy with it for some reason. So, sorry, cutting a long story short, this order confirmation implementation of this screen took me on a long journey of, okay, I'm going to do it this way. Oh, wait a minute. This is not great because this introduces more friction on the user. Oh, this is not great because it introduces less security. Oh, this is not great because it introduces centralized components. But so in the end, I think the solution that I came up with is actually the right one that maximizes all three goals of decentralization, user experience, and security in such a way that it maintains kind of the key objectives of the app, and maintains those objectives, but also it doesn't create any major problems, if that made sense. But anyway, so we have a lot to cover, so I'm not going to continue laboring this point, but I think hopefully that was a useful discussion for you, because for me it was sort of, I went around in circles quite a lot on this one, but I'm very happy with the solution that I got in the end. And one of the things, just to finish on that one of the things also obviously important on that is the shipping details, because shipping details are things that are like have customer sensitive information that we don't want to reveal to anyone. But I needed to store that metadata, of course. If I'm going to deliver the products to the customer, I need to have those shipping details stored, but I needed to encrypt them. And I needed to make sure that I choose an encryption method that doesn't expose any private keys or anything like that in the client-side code. Because if that code got compromised in some way, shape, or form, I don't want someone to actually be able to decrypt anything on the blockchain. So currently, the method that I've applied with public-private key encryption, it makes sure that this is basically literally impossible unless I were to lose the private key of the app, which I'm never going to, because I have a good sort of OPSEC in that respect. But anyway, so that's that. Let's talk a little bit about the Flutter sort of lib folder. So this, obviously, for anyone that has developed Flutter applications before, you know that you spend 90% of your time sort of working on the lib folder. And the lib folder has a lot of subfolders inside of it. I'm not going to read through all of this. You can read for yourselves, but basically I've split this into subfolders that allow me to keep that separation of concerns and have the application code cleanly separate between the different layers of the application architecture. So you have your blockchains, which is an external dependency. This is where I have that abstract class interface where I define the key sort of methods that the blockchain needs to implement, like fetch accounts, fetch user profile, get balance, get recent block hash, like these types of things. So in this case, the blockchain's sort of folder has two files. One is the abstract class itself, but then you also have in this case, the Solana implementation of the abstract class. But I could have, like in the future, I could have an implementation for a Bitcoin layer 2, where I decided to deploy this application also on a Bitcoin layer 2, and this and then that means that inside this blockchains folder, I would have a Bitcoin L2, name of the L2, that implements the same abstract class or interface. Controllers, I only have the one single controller. I wanted to keep it simple. I could have like multiple controls for multiple things. I decided to just simplify the state management of the application and our orchestration and all that. So I decided just to have the one. JS Interop, I have two files in there, the JS Interop non-web and the JS Interop normal. The non-web one is basically it's a trick that I'm using to keep the code clean. It facilitates the Flutter Web Phantom Wallet connection. And as I said, keeps the code clean by avoiding branching logic. I'm not going to go into the details of this now, but basically the JS Interop has functions like, Phantom Wallet Connect and sign-in send transactions and things like that. So these are things that I would obviously have implemented for mobile. I implemented in the Dart code with deep linking, but for web, I've implemented with JavaScript code and some Dart code that kind of does the glue and calls the JavaScript code to talk to the Phantom wallet in the browser, the browser extension. So anyway, I don't have time in this video to go into that. Otherwise, this video would be probably 2 hours. But I just want to make sure that I mention this because it's one of the tricks, and I'll show you in the next few slides how this is actually used. Not the code that's inside the files, but how you do the conditional imports and all these things. So the models are just the Solana data accounts, effectively the admin, the purchase order, the shipping rule, the promotions, the product, so that all of that stuff are basically the models, and it almost one-for-one maps into a Solana data account. Yeah, utils, lots of stuff in that utils. I'm not gonna go into the detail on that. The views, it's all the screens that we talked about earlier in that screen flow diagram, and then you have the wallets, and you have the again, same as in the blockchains folder, you have the wallets folder, which have the abstract class sort of interface, which defines methods like is connected or connect or disconnect or sign and set transaction or public key, which basically returns the public key that is currently connected on the wallet, like things like that. The abstract class defines those methods, and then you can have the actual implementation of this. It could be the Phantom wallet, or could be the backpack, or any other Solana wallet. So effectively, if I want to develop the integrations with those other wallets, I would just basically have to implement that interface to make to keep the rest of the app unchanged, which is exactly what we want. This is why we do this this kind of approach. This is typical. It's not because it's a DApp that we do this. Any good well-architected front-end application, you would effectively do this. Okay, so this is probably the part that most of you want to know. So let's get started with Phantom Wallet integration on mobile. And this is, let me just pause and say this. This is one of the things that I can tell you, I spent countless and countless hours trying to figure out these things on my own, because there is no single place where you can find all of this information gathered in one single place. There are certain when I Google this, there are certain pages online that have a lot of these, but not all of these. So this information is scattered all over the place. And especially when we're talking about integrating with Phantom, oh my God. So things get exponentially even more scattered. It's not that the information is not out there, but it's scattered. And you only find that some of these things are missing when you bang your head against the wall so many times, and then you start like, but why is this not working? And then you figure out why it's not working, especially this red one that I have here. But anyway, let's go through this one by one. So for mobile, obviously the deep linking is kind of what you want to do, but before you even talk about that, you need to install a certain few packages in Flutter. So you need to install the app links for the deep link handling, and you also need the URL launcher to launch the URLs in the operating system. So you need to add these two. And then in terms of building the connection link, so I only talk about connection link, but for instance, if you want to send a transaction, there is another way that the link is built, and the parameters are different. But essentially, I have a link further down that I can share, and in the video description, you'll also have a bunch of links that I'll share with you there that give you all the Phantom documentation. So the Phantom documentation is pretty good, I have to say, but it doesn't. There are certain things in there that I still struggled with, because it's good to a point. It tells you what you need to do, but it doesn't tell you how in certain situations, especially the encryption with shared secrets and things like that. So I'm not going to go into those details again on this video, otherwise it would be 2 hours, as I said. But you know, if you do want these details, please let me know in the video comment section, and I'll make sure that I'll cover that in maybe in a future video. So not only you have to kind of go through the Phantom documentation, so I'll cover the Connect one so that you have an idea what to look for. But then you have the Android specific configuration to get deep linking working, and you also have the iOS configuration. And these two are very, very different from each other. So, hey, Flutter is you know, single code base for the most part, but when it comes to configuring different platforms, it's a little bit of a headache sometimes, especially when it comes to things like deep linking and having that working. But anyway, once you figure out how to do this once, it's never a problem again, and you can do it in less than half an hour. But the first time I had to do this, it was hours and days to get this working, because sometimes I would get 1 or 2 of these working, but then figure out that there was something missing. This one here, avoid underscores in deep linking schemes, is something that after a day, I think, or 2, or day and a half of testing, and as I keep saying, hitting my head against the wall so many times, I finally figured out that in the schemes you just have to avoid underscores. Yeah, let's just remember this. Just have one word, no underscores, no funny business, no funny characters in there. Just one word. Keep it like that, please. Otherwise, you'll just waste your time. And the iOS configuration, yeah. So I'll give examples of all of this in the next few slides, but this is just basically an overview. You need your intent, your queries, and then for iOS, you need to do certain configurations in Xcode. Again, I'll show you all of this and also this element here. So let me just see. Yeah, so that's it. Yeah, so Phantom Wallet link parameters. Yeah, so as I was saying, this came straight from the Phantom documentation. As you can see, it's here, the link, so you can go there on your own time, and you know, there is a ton of information in there. I basically replicated this element here for the connect method, because you can As you can see here, it's for connect, but if you're going to send a transaction, it's a different set of query string parameters and a different set of encryption requirements and things like that. So definitely read in detail those links from Phantom. But this is just to give you a clear idea of how I do it. For instance, for connecting the wallet with deep linking, you need to send all of these things. I'm not going to read through this. You can read it on yourself, but you have, these are all relatively self-explanatory. This is the URL scheme for your app. This is the cluster, where Solana cluster, whether you're using DevNet test. Oh, by the way, I found that Phantom now, one of the things that I was complaining about recently, which was Phantom only allows you to connect to DevNet, testnet, or mainnet, but it didn't have local cluster. Now, guess what? Local cluster is there. I didn't test it yet, but I was extremely happy to see the local cluster there. Why? Because it's a pain sometimes to test in the DevNet or testnet, especially on testnet. But because getting airdrop, there is like a limit on the Sol airdrop that you need, and if you hit the limit, it's a pain to get more. There are ways to circumvent it, but it's very, very problematic. And also the deployments sometimes fail. Well, anyway, there is a bunch of challenges when using these higher test environments, even DevNet, even though DevNet is probably the best one out of the two. Local is great. Local is great. So the fact that now Phantom allows you to do this with local is amazing. I will need to test it, and I'll give you some feedback what I found about like the connecting Phantom to local cluster. But I'm very excited about it. You can see that I am. App URL. Yeah, so this one is actually an exoteric one. It took me a little bit of time to actually understand what this was. So you need to define and host an HTML file somewhere where you define, there's a bunch of criteria for app icons and title and description and things like that. This is metadata about your application that is going to be used by Phantom when the pop-ups come up. If they need to show an icon associated with your application, that's where it gets it from. And you need to display, like you need some tags in your HTML so that when Phantom goes there, it retrieves the actual title, app title, icon, etc. from that file. So you need to follow the right sort of way of defining those things in the HTML. Otherwise, it's just not gonna show the icon or not gonna show the correct title for the application. So again, if you need more details on how to do this properly, I can share with you how I've done mine. I managed to get it working perfectly, and more recently it changed. Like it seems to be having trouble again. So I don't know if the trouble is on my side or if it's just temporary glitch from using the test environments, but I will try and see if I can make it work again, and I'll share those details with you if you want. Let me know in the comment section below. I will be saying this quite a few times, but there is so much detail. I could be talking about lots of details on this video, but unfortunately I'm already 70 minutes going, and I'm nowhere near the end. I still have probably 10 more slides to go. But anyway, so let's go. That's connect. Then I have this configure deep links for Android. So this is the two intents that are required. So these intent filters are they basically ensure that your app can handle the callbacks when the Phantom wallet interacts with it. So as you can see here, I defined the scheme, which would be a name for the app, and then the connect callback, and the same thing in this case for transaction callback. So I have two different callbacks. one for when for the connection callback and one for the sending of transaction callback. These are the only two ones that I needed to define so far, and they are working well. And then the other thing that I'm doing is defining the queries that support the Phantom URL scheme. So this basically ensures that your application can interact with Phantom wallet URLs securely. I think without this, I'm not entirely sure if you would be able to really launch the Phantom app in the Android operating system. So this is, if you do these two things, you're fine. Yeah, so, and as I said before, please do not use underscores in your scheme here. When you define the scheme, please do not use underscores. Even if you use, because when I was using underscores, like saying, for example, my soulful underscore sellers. So if you use something like that, it's not going to work. But it's quite the error is quite pernicious, because you can run those commands like adb shell Android commands, that you can give them an intent, one of these intents, as part of the command line. And then you can say, oh, I'm testing this connect callback, for example. And when you run that ADB command to simulate a deep link callback into your application, the application actually gets revived from the background, and it executes correctly. The code executes correctly. So from the command line, from an ADB command line, actually you can trigger successfully even if your scheme is named with an underscore. Unfortunately though, when the callback is done from Phantom, not from the ADB command, it just doesn't work. I tried and the app would not come back on the callback. So the app would successfully trigger the Phantom app to show. So you would see your app here, and then you launch the Phantom app connection, and then Phantom app comes on the foreground. And then when you do the action, let's say connect, you click OK, and then your app wouldn't come back because the deep link is not like being handled properly because it had the underscore. But if you remove the underscore, magic, everything starts working. You cannot believe how many hours I lost because of this, until I figured out, okay, could it be because of the name? And then it was. Oh, I felt like, oh, I'm gonna kill someone. I'm sure you've all been through that before. All right, okay, let's go. Next one. So this is talking about how to configure deep links on iOS. So it's very different compared to Android, but one of the things you can see is that, so you have to open, even if you're using VS Code like I am, for this particular one, I've just found it easier to do it on Xcode. So I just, right click on your iOS folder in VS Code and say open in Xcode. Right click in VS Code, your iOS folder of your Flutter project, and select the option to open in Xcode. When you do, you see a window like this. So all you have to do is click on that runner. Then you click on this info tab. And then you will see these URL types that I mentioned here. And then you can see this. And this is basically, you have to define your custom schemes, and you have to define your you set your role as editor. That's it. It's very, very simple. And now the next and final one, you would have to do enable your associated domains. So you would have to go to, in the same sort of Xcode, you go to signing capabilities, and you'll need to add the associated domain capability, which is in here, and configure it with the necessary Phantom URLs. I got this I believe, from Phantom themselves. But yeah, so this is one of the things that you need to do on iOS. Last but not least, you have the app delegate Swift file, which you need to update. Now, one of the things that you will see is that there is this element here of the code. Okay, so let's take a step back and just talk about this for a second. Normally, in a Flutter application, you don't typically need to edit these files. However, because we're talking about deep linking, we have to actually edit this file. This first section here of the file is standard and it's always there, and you normally don't need to touch this. In this case, what I needed to add was this part here, the bottom part, this override here, right? So I'm not gonna, Swift is not my expertise either, but from what I could gather, what this is doing, this is very much like in other languages, registering an event handler with the iOS platform to let us know in the Flutter sort of Dart code that a deep link interaction was triggered. So we have the trigger, which is the deep link event. We have the listener, which is the application continue user activity, which is effectively this here, and which it's a method. And the handler is effectively this element here of the code, which is invoking the method channel to pass the URL that responds to the event communication with Flutter. So this approach gives our Flutter application the ability to react to external events coming from the iOS system. So with these sort of configurations, the user doesn't need to manually switch between our app or copy paste data from our app to the Phantom app or anything like that. All of this is done automatically. Again, I'll show you this in the next video. It's going to be one of the things that I'm going to show in the next video is all of this theory that I'm kind of talking through right now. I'm going to show a live demo. I've already shown a demo of this in one of my first videos that I've done on the Solana smart contracts, but now I think it's appropriate. Now that I've spoken so much about all of these configurations, I think it's better to just show you. And also, I never shown the web app, so I will show you the same code, trigger the web app, trigger the mobile app, and as you can see, it's the same code that is triggering both. And you will be able to see all of these interactions in a live in a recorded demo that I'll do, and I'll show you exactly what I mean with all of these things. But it's quite amazing to see it all come to life and working after all of these configurations. 1,001 configurations that are required to actually make this work. Jesus. Just looking at my notes to see if there is anything else that I want to say here. Yeah, so I had a note here about that there are some further elements on the deep linking handling that are required in obviously in the Flutter code, like how to receive the callbacks and how to handle the callbacks from the deep linking. I can, if any of you have trouble with that, I can show you how to do that. Obviously, the libraries that I've told you about in the beginning that you need to import, those two, the URL launcher and the app links one, those two are the key ones. But if you want some guidance on how to use that to handle the callbacks, then please do let me know. I'm more than happy to help. Next one, let's talk about, we're almost getting to the end, so let's talk about the Flutter web. Sorry, so this slide is very busy, but let me give you a tour. So in order to configure the Flutter web, you need to do a few things. So first, you need to change your index. So inside the web folder, which is where your web project in Flutter lives, you have an index.html file. Inside that, you have your you will basically have to update that file to do a few things. The updates are basically here. I'm showing you what you need to do. So you need to, inside the head tag, you need to put the buffer JavaScript file. I downloaded this file from the internet. Again, hopefully I won't forget, but I'll put the link to this file so that you can download it as well. I also have this script, the Phantom JS script, and I also have this Web3 one, the Solana Web3 one, which in this case is retrieved straight from the internet. So I basically put it in here as well in the head. And then this one, it was already there, the Flutter bootstrap.js. That's default. It's always there. But I added this other one, which is the phantom.js. Now, phantom.js is the one that has all the JS phantom functions that I call from the Dart code. So the connect function, the is phantom installed or is phantom there, the send and sign transaction. So all of these functions are defined in JavaScript that basically interact with the browser extension. They're all there in this phantom.js. Again, don't have time to go over this right now in this video, but if you need some help with this, please do let me know in the comment section. Then we have the JS Interop setup. As I said, I created in the lib folder, I created a JS Interop folder, and I created these two files inside of them, the JS Interop underscore non underscore web dot dart, and then the JS Interop dot dart. This one is basically has the same function definitions as this one. The only exception is that this one does not define them. It basically just throws a not implemented exception. And this one actually does define them. Again, I'm not going to go into the details. I think I explained this a little bit in the very beginning, but this is basically the way to then when to do these conditional imports that you see here. So if I am running this application in web, it imports one. If I'm running in mobile, it imports the other one. The issue, this is never an issue that they're not implemented in the mobile platform version of the import because it never gets called. And the reason is this third box here. So this is the only conditional branching that I have in the entire code, which is quite good. So very localized in two places, in the place that I connect and in the place that I send transactions. That's it. That's the only two places. And it basically uses this if k is web variable. So if k is web, which means if this is true, it means that I'm running in a browser. If it's false, it means I'm running in a native platform like iOS or Android. So in mobile, basically, that's what I meant. So if k is web, then these two that you see here, they're basically defined in the phantom.js, but this code doesn't call phantom.js directly. What it does is it calls the JS Interop.dart, which has these two functions, and then from there it calls the phantom.js. Hopefully that was clear. And as I said, in the mobile, it doesn't import this one. It imports the non-web, which has the undefined sort of throwing not implemented exceptions versions of these, but it's fine because they're never actually executed because this is false, and therefore these are never called. And it goes to the section, to the path of the code that does the deep linking version of the interfacing with Phantom. I know this is a little bit complex, but again, if you need my help, I'm always here, more than willing to help. Just let me know in the comment section. And lastly, once you have done all of these things, you can run Flutter build web, or if, like me, you're having trouble with your web application because it's not rendering properly, it's giving you a few issues. I was having some issues with that, but not always. I've had situations where I've run Flutter build web and then go and run it, and it runs fine. Other times with the more advanced rendering engine, don't know if it's OpenGL or something like that. Anyway, it worked fine, but with this particular one it didn't, so I had to actually add this command line parameter, the web renderer, to tell it to basically compile it to use the less sophisticated sort of rendering, and that worked fine. I didn't really see that any major sort of graphical problems with it. It kind of ran fine and looked fine as well. And then finally, what I did was, after compiling the Dart into JS code, which is effectively what the web app is doing, then I basically had to serve the app locally just to test it properly by running, for instance, I was using Python. You can use whatever web server you want, but I was using Python, and I ran it from the build web folder, right? So you have to position yourself to inside the build web folder, and then you run this from inside that folder. And then in the browser, you just access localhost :3000, and then off you go. You can access it. So in conclusion, I'm not gonna, because it's already very, very late. I just want to say we went through a lot of stuff on this video. I should have probably split it in two, but I was lazy, so I just wanted to get it out of the way. So I did it in one long video. Sorry about that. So we talked about the challenges in developing decentralized applications, and talking about decentralization, user experience, security, and trying to maximize these competing goals. That's always obviously a fine line that you have to walk, and it's a little bit tricky. We talked about the Phantom wallet and the interaction with the Phantom wallet and the Solana blockchain, and the fact that there are read and write operations, and that for some you have to go through the wallets to get customer approval, and for other interactions you can just read them straight from the blockchain via the RPC channel that gives you access to that Solana blockchain. And so how do you architect the application to take advantage of these two different ways of accessing the blockchain, the Solana blockchain in this case? We talked about the screen flow, the different screens that I've developed for my application. We talked about the lib folder sort of structure and the different things that I the different folders that I created in my DApp to keep the code clean and modular and all that. We talked about the Phantom Wallet integration for both mobile and web. For mobile, we use deep links. For web, we use the JS Interop from the Dart code. And we talked about like the different nuances of configuring this. For Android, you do certain things with the intent filters and the queries and all that. For iOS, we talked about the Xcode configuration elements and what you need to do in order to get that done. You also need to read the Phantom documentation to know how to build the URLs that you need to launch the Phantom wallet. I've shown you specifically for the connect one, but you also have a different way of calling the sign and send transaction. Again, if you need any help with those, please let me know, and I can share some code snippets on how to do that properly. So yeah, so I think this is all sort of all the points that we covered in today's video. So looking ahead, so in the next video, I'll dive into topics like the transaction encoding and querying of the blockchain, which is super, super important on how to do that properly. And I will also obviously demo the app for both web and mobile. I think after such a long video today, it will be good for you to actually now see the app alive and well and doing all of these things from a single code base, which is excellent. And doing all of these interactions with either web or mobile deep linking yeah, seeing how it works. So thank you very much for following along. I hope this presentation, even though it was long, gave you, a clearer understanding of the key components of the DApp development and Solana and how to integrate the Phantom wallet across different platforms. I wish personally that I had all of this knowledge when I first started. This presentation, trust me when I say that it's the result of countless hours that I spent basically overcoming these various challenges and documenting those pain points along the way. So I was, as I was developing and finding all of these problems, I was, documenting all of these things separately. And I was really trying to say, okay, one day in the future, I'll do a video where I'll explain to people how all of these things were a challenge, and how actually how do I make sure that I convey these insights to others so that they don't have to go through the same pains that I did. So this is the result of that. And if you'd like, any more code examples, as I keep saying, and I said it many times during this video, please drop a comment in the comment section below. I would be more than happy to help you on your coding journey. And please don't forget to, if you found this useful, please don't forget to like, to subscribe, and to hit the notification bell so that you get notified when I release my next video. Thank you very much. Stay empowered, stay decentralized. Bye-bye.